On August 15, 2025, a historic moment unfolded. China unveiled its very first commercial e-beam lithography machine, a technological marvel that has been years in the making. This achievement marks a major milestone in China's quest for technological independence, signaling a new era for the nation's semiconductor industry. Developed through a collaboration led by Zhejiang University, this breakthrough propels China into the exclusive club of nations capable of mastering and producing advanced chip-making tools, an accomplishment that was once thought to be out of reach. The machine, named Shiji, stands as a cornerstone in China's determined push for self-reliance in high-tech manufacturing, representing years of research, investment, and national ambition. By building its own chip-making equipment, China is taking concrete steps to reduce its vulnerability to foreign restrictions, sanctions, and unpredictable supply chain disruptions that have previously threatened its tech sector. This isn't just a technical win, it's a calculated and strategic move in the ongoing global tech race, where innovation and control over key technologies determine economic and political influence. For decades, only a handful of countries like the United States, Japan, and the Netherlands could produce such advanced tools, maintaining a tight grip on the global semiconductor supply chain. Now, with this achievement, China joins their ranks, breaking through barriers that once seemed insurmountable. The Shiji machine signals a significant shift in the global tech landscape, introducing new competition, fresh possibilities, and a rebalancing of technological power. Soon, Chinese tech companies will have access to homegrown, cutting-edge tools, empowering them to innovate faster and more independently than ever before. This achievement is just one part of a much broader long-term effort to strengthen and modernize China's entire technology ecosystem, from research and development to manufacturing and global collaboration. The world is watching closely as China takes this foundational step, with international media and industry experts analyzing every move and its potential impact. It's not just about one machine, it's about shifting the balance of power in global technology and redefining who leads the next wave of innovation. With Shiji, China demonstrates its rapidly growing prowess in research, development, and high-tech engineering, inspiring a new generation of scientists and engineers. This move could unlock a new era of Chinese innovation, driven by domestic capabilities and a renewed sense of national confidence. The global tech industry is bracing for the impact of this new player, as China's advancements promise to reshape competition and collaboration worldwide. China's ambition is clear: to become a top contender in the global semiconductor market and to set new standards for technological excellence. This leap forward is a bold message to the world. China is ready to compete at the highest level, and it's only just getting started. The implications of this breakthrough go far beyond technology, influencing global economics, supply chains, and even geopolitics in ways that are only beginning to unfold. As China builds on this success, the global chip race enters a new, more competitive phase, with higher stakes for everyone involved. The era of Chinese-made advanced chip tools has officially begun, and the world will be watching to see what comes next. Lithography is the art and science of printing incredibly tiny, microscopic patterns onto silicon wafers, the very foundation of every computer chip in existence. These patterns are so small that they are measured in nanometers, a scale thousands of times thinner than a human hair. Think of lithography as a form of ultra-precise photography, but instead of capturing images, it creates the intricate circuits that power our smartphones, laptops, and countless other devices we rely on every day. The finer and more detailed these patterns are, the more powerful, efficient, and energy-saving the resulting chip becomes. This is why constant innovation in lithography is so important. Without advanced lithography, the sophisticated electronics that drive our modern world simply wouldn't exist. It's the invisible engine behind technological progress. While most lithography uses light to etch patterns, to push the boundaries of what's possible, E-beam lithography employs a focused beam of electrons. This allows for even smaller, more complex, and more precise circuits than ever before. This cutting-edge technology is absolutely crucial for manufacturing the most advanced chips used in artificial intelligence, supercomputers, and next-generation electronics. Over the decades, progress in lithography has fueled rapid advances in electronics, shrinking devices while boosting their capabilities and speed. Gaining mastery over this process means having control over the future of technology itself, influencing everything from consumer gadgets to national security. China's recent breakthrough in e-beam lithography gives it direct access to this critical step in chipmaking, marking a significant milestone for its tech industry. No longer fully dependent on foreign suppliers, China can now experiment, innovate, and develop new technologies with greater freedom and confidence. This new capability is a true game-changer for China's technological ambitions, opening doors to global leadership in electronics. It secures China's place in the digital world, supporting its drive for self-reliance and technological independence. The new e-beam lithography machine empowers Chinese engineers to design and manufacture the next generation of chips, pushing the boundaries of what's possible. This is more than just a technical upgrade. It's a strategic advantage that will shape the direction of China's tech industry for years to come. With this solid foundation, China is now poised to shape the future of electronics, both at home and on the global stage. Meet Shiji, China's state-of-the-art e-beam lithography tool, designed and built entirely within the country. Using a highly precise electron beam, Shiji draws incredibly intricate circuits directly onto silicon wafers, making it perfect for prototyping, research, and specialized chips that require the utmost accuracy. Years of dedicated research and development at Zhejiang University's renowned quantum lab made this technological leap possible. Shiji's commercial debut is a milestone, proving that China can now independently build sophisticated chip-making equipment once thought out of reach. This breakthrough reduces reliance on foreign suppliers, strengthens China's supply chain resilience, and helps secure the nation's technological future. The machine's arrival gives Chinese companies a reliable domestic option for advanced chip production, boosting confidence in local innovation. In today's tense global trade climate, having homegrown technology is a major strategic advantage for China. Shiji isn't just a research project, it's a fully operational tool, ready for real-world, high-volume manufacturing. Its success stands as a powerful symbol of China's rapidly growing technical expertise and ambition in the semiconductor field. The name Shiji hints at a new beginning for China's tech industry, representing hope and a bold step forward. While one machine alone won't change the world overnight, it's a powerful sign of progress and a glimpse of what's to come. Expect a ripple effect, more innovation, increased investment, and a stronger, more competitive high-tech sector across the country. This is just the start of China's next chapter in chipmaking, with even greater achievements on the horizon. China's drive for chip-making independence is a direct response to years of export controls and restrictions. Blocked from buying the world's most advanced equipment, China doubled down on developing its own tools. The Shiji machine is a bold answer to these challenges. This strategy, localization, aims to keep China's chip industry growing, even without foreign suppliers. It's a calculated move in the ongoing tech rivalry with the US. Restrictions intended to slow China have instead fueled its innovation. Chinese researchers have learned to build what they can't buy. If China achieves full independence in semiconductors, it will be immune to future export controls. This could fundamentally shift the global tech balance. Ironically, the barriers meant to hold China back may have sparked its technological revolution. The chip industry is a high-stakes race, and China's new machine is a game-changing entry. Advanced chip making is the ultimate prize, key to economic power and security. China's progress signals it's now a serious contender. The pandemic exposed fragile supply chains, pushing nations to build their own tech capabilities. China's rise puts pressure on established leaders like the US, Taiwan, and South Korea. The industry may see new supply chains and shifting alliances. China's Shiji machine could disrupt the dominance of companies like ASML. The global tech map is being redrawn, with new rivalries and partnerships emerging. The race is on, and China is accelerating fast. China's chip strategy follows two tracks: e-beam and DUV lithography. E-beam is perfect for high-end, low-volume chips. DUV, or deep ultraviolet, is the workhorse for mass production. Mastering DUV is essential for a large-scale chip industry. China is investing heavily in both, ensuring it can meet demand for everything from AI chips to everyday electronics. Domestic DUV machines would secure China's supply of essential chips, even under international restrictions. Progress in DUV is a true test of China's semiconductor ambitions. Success means a stronger, more resilient manufacturing base. E-beam is the fine-tipped pen, DUV is the high-speed press. Both are needed for a complete chip industry. China's dual approach shows a comprehensive, long-term vision. It's about building a full toolbox, not just one breakthrough. This strategy positions China to cover all bases in the global chip race. Chipmaking isn't just science, it's geopolitics. The US and China see tech leadership as vital to national security and economic strength. The US has tried to slow China's progress by restricting access to key technologies. Semiconductors and AI are at the heart of this rivalry. Every breakthrough, like Xi, is both a technical and political statement. China's message: it won't be held back by external pressure. The world could split into separate tech ecosystems with huge consequences for companies and consumers. The race for chip supremacy is shaping the new world order. Technology is now a central front in global power struggles. China's breakthroughs are driven by a powerful push for self-sufficiency. Years of restrictions convince China it must control its own tech destiny. The goal: a complete ecosystem for designing and manufacturing advanced products. Massive investments in R&D and support for local companies are fueling this effort. The Xi machine is proof that focus and resources can overcome huge technical barriers. Achieving full self-sufficiency is a long-term mission, not an overnight fix. It's essential for China's future security and global leadership. The journey is tough. Mastering one machine is just the start. Building an entire industry requires expertise, skilled workers, and time. China is making progress, but catching up to established players is a marathon. This breakthrough is a major victory, but the race continues. China's first commercial e-beam lithography machine signals a new era in global technology. For China, it's a leap toward tech independence and innovation. The move challenges established leaders and intensifies competition. This could spark faster progress and lower prices, but also a more fragmented market. Companies and countries must adapt to a shifting, complex landscape. The link between technology, economics, and politics will only grow stronger. As China closes the gap, expect continued geopolitical tension. The Xi machine is more than hardware, it's a symbol of a new global order. The future of innovation will be more distributed and competitive. The chip game has changed, and the world will feel the impact for years. China's determination is reshaping the future of technology.